Large language models are becoming smaller, which means that they are becoming more accessible for everyone. The field of AI has seen significant progress with the development of LLMs, which have shown impressive performance across various natural language processing tasks. However, the growing size of LLMs has led to challenges in deployment, particularly due to high energy demands and related environmental and economic impacts. A solution to these challenges has been found in post training quantization, which creates low bit models that require less memory and computational power, with a recent trend towards 1 bit models that maintain performance while being more cost effective. BitNet b1.58 represents a major advancement in 1 bit LLMs, offering a ternary parameter system that uses values of -1, 0, and 1, effectively operating at 1.58 bits. This new architecture significantly reduces the memory footprint and computational intensity compared to traditional 16 bit models, leading to faster and more efficient inference. BitNet b1.58 retains the benefits of 1 bit models, such as minimal multiplication operations during matrix multiplication, and exhibits strong modeling capabilities due to its ability to filter feature explicitly. If you look at this diagram from this paper, it provides a Pareto solution to reduce inference cost, which is latency, throughput, and energy of LLMs, while maintaining model performance. The new computation paradigm of BitNet B1.58 calls for actions to design new hardware optimized for 1 bit LLMs. In context of AI, a Pareto improvement refers to a situation where an adjustment to an algo or system result in a benefit, such as improved accuracy, efficiency, or speed, without causing a detriment in other areas like increased bias, higher computational cost, or greater energy consumption. It is a multi-objective optimization where one aims to enhance one aspect of system without negatively impacting others. For example, if an AI system's performance is enhanced by an algo update that accelerates processing speed without requiring more computational resources or degrading the quality of outputs, that would constitute a Pareto improvement, and that is what is being shown in this diagram. Now, in machine learning model development, Pareto improvements are particularly significant when considering trade offs between different performance metrics such as precision and recall, or between performance and resource consumption. The goal in optimization is often to find Pareto optimal solutions where no single metric can be improved without worsening another, signifying that the model is operating at a point of efficient trade offs between various objectives. The introduction of BitNet B1.58 has notable implications for the deployment of LLMs on edge and mobile devices, which are often constrained by limited memory and computational resources. The reduction in memory and energy requirements allows these sophisticated models to operate effectively in resource restricted environments. This paves the way for broader applications and enhances the capabilities of such devices, with BitNet B1.58's efficiency and performance making it particularly suitable for CPUs, the predominant processor in mobile and edge devices. So, exciting times ahead. Let's see what is getting produced after this new research. I can't wait for it, and I think this year 2024 will see lot of evolution on the basis of researches like this. That's it, guys. Let me know what do you think about these 1 bit LLMs. I'm quite excited about it. Please share your thoughts in the comments. Also, if you like the content, then please consider subscribing to the channel, and if you are already subscribed, then share it among your network as it helps a lot. Thanks for watching.